All right, I'd like to start with you, Will. It's glad to be on the panel with you. We know we're often not together, although, as you see, mineral exploration and mineral processing is becoming an important topic. I know you. I want to talk about your involvement with your company first, Mitra Chem. Could you tell a little bit about Mitra Chem? We talked a lot about machine learning and at this conference. I think we'd like to hear about what Mitra Chem is doing, and there was a lot of questions during the forum around battery chemistry and where that is going. So they're all waiting for an answer.
And I have the entire 40 minutes. Well, Jeff, first of all, thank you so much for inviting me to the symposium. What a great turnout, what a great day. And I'm just so pleased to be here meeting you all. Let me say a few words about the founding of Mitra Chem, a company that started in 2021. The idea actually came out of a class here at Stanford called Stanford Climate Venture. Actually, it did not directly lead to the company, actually led to the first pivot before the company was founded. So in the late 2010s, I have been working with a colleague in computer science, Stefano Orman, on the application of AI to accelerate battery materials discovery and also the R&D cycle for battery development. And a few of my students who were involved in the work took a class, Stanford Climate Venture, to think about how to commercialize AI technology for batteries. Now, this is way ahead of its time. We started the work about 2015 when the two words, AI and batteries, really didn't come together yet. And the idea that came out of it was, wow, we can start a company offering AI as a tool to enhance battery manufacturing, battery material development. But out of that class, the conclusion was, this is maybe a $10 to $100 million type of idea, but not the multi or tens of billions dollar idea. And actually that led us to the pivot before the company was formed. So none of the students that took the class were part of the company because we realized if we really truly believed in what we discovered via data science, AI, and big data, then we should bet on those ideas ourselves rather than providing it as ideas for others to bet on. So the company was founded in 2021 with my two founders, one from the Graduate School of Business and one from Toyota Research Institute, also an expert in AI, to really combine AI for R&D, AI for scaling up, and AI for production optimization, and devoted it to one specific product, and that was iron-based batteries. And I think most in the room know, and as indicated in the title of this panel, the technology we picked was lithium iron phosphate. Turns out there was a huge amount of optimization to be done across those three areas: the R&D, the scaling up, and the manufacturing and achieving profitability. So what we decided to do in a very simple nutshell was to pick a product and use AI to improve every aspect of it. And now the company has raised a little bit over $250 million to achieve that particular vision. And I think we are looking at the birth of a new way of doing R&D, a new way of doing scaling up, and a new way of doing manufacturing applied to a very specific chemistry. So that's a very brief scope of what Mitra Chem is and how we are using AI specifically for developing and manufacturing LFP battery materials.
Yeah. I want to move to you, Ed. You're a person with extraordinary experience in the real world in commissioning, building infrastructure. You've attended the last 2 days. You heard about AI and new technology and revolutionizing. What is your take on all this, this role for AI and production optimization when you actually go into the real world and you have to build the infrastructure?
That's very good. First of all, it's a pleasure to be here, Jeff. Thanks for having me here. Artificial intelligence. Two things that I'm looking at as a business and my experience. One obviously is with digital twins and being able to develop the testing and the simulation for that. Analytics, predictive analytics, that's a big thing and we're working towards that. But I also see artificial intelligence, okay, in my realm when it comes to commissioning is the tools, the equipment that the people in the field are going to use to be able to execute projects with precision, with discipline, have accurate reporting, and be able to identify gaps. We want an early discovery. So if we have those tools available for us during this process of commissioning, it's going to make a lot of big difference. Now, when it comes, with artificial intelligence, just things that we're looking at. We have 20 nationalities in our company. We're just doing a project in Indonesia. There's Chinese speaking, all of that. There's projects in Greece that we're working on. In Argentina, I just got back this weekend from Buenos Aires, in Peru, and obviously United States and Canada. One of the things that I feel that's amazing, that could be, is being able to use artificial intelligence when you communicate in different languages. That would be an ideal thing to have, and I see it coming. And that would be able, just looking at ChatGPT, a procedure in Indonesian, or Bahaya, sorry, and in Spanish, you have it. You can standardize the methodologies. And in commissioning, we cannot have errors. And this is where I see AI working as commissioning. Now, as far as process controls, now you're looking at automation, and that's something that we've really focused on. Now we're looking at things as, digital twins, but also looking at alarm management. That's one thing that always kicks us in the butt. Rationalization, ensuring that we don't have a million alarms on your screens and people are acting towards what's required. Definitely, that's where AI comes in. And I can go on, but I see a big future with artificial intelligence coming into the force. And from my points of view, both in the commissioning execution and in the process controls, the automation, it's there. Now we can also look at operational readiness and the operationalization of the workforce and the people and the training. You're opening up Pandora's box, and there's a lot of things that can be done.
Thanks, Ed. So Abdellatif, until 2 years ago, I did not know where phosphate came from. And as you know, most of the world's phosphate is mined in Morocco. So if we're going to produce that phosphorus for these batteries, we also now, as you know, in our collaboration, are looking at the entire value chain from exploration to processing. And one of the, as people may not know, but one of the byproduct of the processing is phosphogypsum. Could you tell a little bit more about this waste product? What are the concerns that we have now? What is Morocco doing with it now? And what is the company that is producing these products? What are they planning to do in the future to mitigate some of these wastes?
So first of all, thank you, Jeff, and Mineral X team for the invitation. It's great to be here. So before just answering this question, I will just give some few information about phosphate production in Morocco. So as you know, Morocco is holding more than 70% of world reserve of phosphate, and we are feeding the world. And throughout the process of phosphate valorization and transformation, we have different streams of waste, which is really normal and common in every mining industry. But the most challenging one is phosphogypsum. So phosphogypsum is more generated during transformation of phosphate to phosphoric acid for fertilizer production. What we are doing now, because we are producing huge quantities, because stoichiometrically talking, for each 1 ton of phosphoric acid produced, we are producing a little bit 3 to 4 tons of phosphogypsum, which is a secondary tailing that are produced. The main concerns, challenge that we have is to find lands to store these materials. And when we say storing at the surface, this implies a lot of environmental monitoring and geotechnical monitoring. This option is what we call the base case scenario for tailing management, but now the university and OCP are more working on waste valorization, because it is a challenge today, but it can be an opportunity. Why? Because I can just ask you one question. In your opinion, what is contained in a phosphate rock? What other chemical species that we can find? Anyone? We can find in the phosphate rock more than 30 chemical species, including uranium, including rare earth elements, fluorine. So today we have some strategies in phosphogypsum valorization. First of all, we have, but they are still in the pilot scale. There's now like, for now, industrial application. The first one is like recovery of uranium. The second one is fluorine recovery. And there is other pathways like the use of this phosphogypsum in cement and construction materials, because it's simply gypsum, calcium sulfate. But I think this challenge of valorization, there is a problem of scalability, but in my opinion, the most challenging aspect is the regulation and policy framework.
Great. I want to switch up the gears a little bit with you, William, and now talk a bit about your role as director of Precourt and potentially also faculty member here. So at MineralX, we talked a lot the last couple of days of that we put academia on its head in the way that we say we first collaborate with the industry to show it works and then rewrite a publication. What is your thought around how academia, given the climate that is now arising in the Department of Energy, National Science Foundation, what are your views on how academia, and particularly the Precourt Institute, is going to collaborate with industry and create meaningful projects for students and funding so they can work on their projects?
Wow, this is a tough question. Let me start by just re-emphasizing that the core mission of universities like Stanford are research and education. I am a huge fan, this is just my personal opinion, is we do the research in order to educate the very best people. So ultimately, everything have to point back to our trainees at the end of the day. A vast majority of our training go on to do great things in industry. Some of them start companies, some of them work in startups, other work in large corporations. I think to understand Stanford's unique position that's at the intersection of industry, Silicon Valley, and academia is one of the most critical tasks of a modern university. And the way we've been thinking about this is we need to first and foremost figure out how to frame the right question. And to frame the right question, it is important to talk to the practitioners. And for many of the fields we are in, like mining, materials, batteries, the practitioners are not inside academia as much as Jeff and I would like to think we are, but the reality is the practitioners are outside of academia. So I view interacting with industry as a very necessary step to figure out how to frame the right questions. We are very well positioned to do fundamental research. We are very well positioned to do open research, but all of those will have the right level of impact if we frame the right questions. And at the Precourt Institute, we interact with a wide range of companies in many industries to figure out how to frame the right question. And I'll just highlight one example, a new way we have been piloting over the past 2 years through one of our flagship program called STEER, which is a strategic analysis think tank on everything related to the energy transition. And there we're also flipping the publishing model a little bit. There, we first hold a meeting very much like this one with a particular value chain. For example, in a month, we'll have a meeting in Washington, D.C. on the nuclear fuel cycle, and we invited 60 companies in the nuclear fuel space, the miners, the processing, the refining, to figure out what are the right questions to ask. Then we go home, do our homework, perform our strategic analysis, and then we come back with a preprint, which then we share with the public, including all the companies and the practitioner we brought together, and have them look at it. But we don't publish it then. We post it online, get everyone's feedback from industry, which nominally do not participate in the peer review process, and then we submit it for peer review. We felt that by adding 2 layers of peer review, one by the practitioners and another by fellow academics, will give us the best chance to make sure that the work we do, in this case strategic analysis, then are meaningful, applicable, and relevant. So in short, I think the big opportunity for academia to rethink about its role is to be very well connected to practitioners. I think one of the best examples at Stanford would be our medical school. Our medical school are extraordinarily well connected to the practitioners, the medical doctors. They're connected to the patients. And if you think about the same way for the work that I do, for example, as a material scientist, then we need to be working with the people who mine, process, refine, transform the materials so that our work on the fundamental science and engineering can have a good impact.
Great answer. I want to just turn to you again, Abdellatif, because I want to follow up a little bit. The situation at UM6B, and anyone can visit UM6B. It's an amazing place. It's very beautiful, a very beautiful campus. You are a very well-funded group. I got an email or a post about 9 PhD students that we were looking for. How do you see the relationship with the company, OCP, and the university? How do you see that evolving? Is there a problem around that you will be forced to sort of work on the problems the company is interested, or you have more academic freedom? How is that relationship going?
It's like an important question. I think we have like a mix of both of what you have said, Jeff. I think let's talk a little bit about relationship, academia, industry, and knowing that the university is very, very young university. At the beginning, really the relationship was really tough. It was really hard because in general, it's really difficult to make an arrangement between industry, what they are looking for, and academia. Sometimes they think that we are crazy and there's like a reality. But I think by the time we have built a relationship of trust, so now how we are organizing our relationship, our collaboration is like, first of all, we try to have like a mixed team between industrial people from OCP and researchers from the university are sitting at the same table and discussing problems and discussing what would be the best methodology that can like guarantee let's say what the company is looking for and what are the researcher is the freedom of the researcher. So for today, we are like working on two kind of project, what we call like a short-term project, which are like more applied project to a very specific problematic. Sometimes that project is like maybe 6 to 9 months, but we have what we call like the long-term project for like more than 3 years, 4 years, where we have more freedom to work, something that more risky project that with more risk and that not necessarily applied today, but maybe one day will be applied for the company.
Great. I want to turn a little bit, Ed, to the international collaboration and the kind of subject matters that we talked a lot. You saw the regions that we covered, like Asia, Africa. There was a lot of talk around building value chains, right? Say, we're not just mining it and sending it to the port. We want to have infrastructure that does processing, et cetera. So since your company is involved in these kind of things, could you speak a little bit out of experience? And I think one that you mentioned is Indonesia, of how realistic this all is, given that everybody wants to do their own thing in their own country. Could you sort of talk around, you have some experience in building this infrastructure, so could you talk around that a little bit?
Yes, of course. Well, I live in Salt Lake City, so there's a big copper mine that has pretty much the whole value chain from the pit all the way to the refinery. So if you look at that model and you look at, for example, what's being done in Indonesia with Batu Hijau, it's a smelter and a refinery, and they have a concentrate on a concentrate expansion. So, that's feasible. But in areas, for example, that I spent quite a bit of time in Salta, up in northern Argentina, and on the lithium, and I'm sure there's other projects going on in that area. It's quite a bit of movement. But infrastructure and being able to build, I guess call it the culture for each one of those value chains from, I'm thinking mining, I'm thinking concentrating, I'm thinking pipeline, I'm thinking water, desalination maybe, all of that all the way to the end product refinery. That's going to be tough. And one of the things I understand, for example, with lithium, I think you want to do the battery grade closer to where it's being is going to be delivered. So is it possible? I believe it is. As base metals, I think it's possible. But then again, you have to look at the economics of that. Spend a lot of time in Chile. Most of that they ship is concentrate. Peru has the Hilo smelter in southern Peru. But you know, when looking at a whole value chain, as I've seen in at Kennecott, you know, and putting it like that, that's a big operation. Morenci is doing something similar to that. They have but you know, they don't have a smelter. But that's going to take a lot of thought. And one of the things that I look at, it's workforce and having the people to be able to deliver and to maintain that and expand that. And you're talking about big operations here. So that is possible. It's just how do we do it, and you know, and creating that culture within a nation. I did work in Dominican Republic on the first back 2011, and build that. You know, it took them 10 years to build a good infrastructure. I saw it in Chile back in the 90s when Escondida first came up, and now it's a powerhouse. And it's built in that culture. I think Indonesia, Mongolia, with Oyatulgi, they developed quite a bit of that culture of development. But building that culture of people, workforce availability and development, that's key to accomplish something like that.
Yeah, great. William, also stepping a little bit back now, we have at Stanford had a very long tradition in mostly in a lot of downstream, midstream processing. There's now an opportunity, as you see, to include upstream, et cetera. If you would think of a region or international collaboration on sort of getting us two in the same team, what ideas would you have? What regions, what companies, do you have any thoughts on that? I mean, I'm looking for ideas myself, so maybe you have some.
You know, I think there are so many, but since Indonesia was mentioned, and I thought I'd just point to a timely example. We recently held, just 3 weeks ago, a summit, Southeast Asia Summit on Sustainability. And we were able to have about 600 really great folks come from Southeast Asia to talk about what sustainability means. And not surprisingly, the two things that really came up was minerals and materials and energy. And in that context, Indonesia was near the very top of the discussion items. The reason why I think countries like Indonesia is a very good complement to California is because the requirements for, say, the energy transition is entirely different for the region. Sometimes, sitting in California, we think of the energy transition is going very well. But that's only in our little state. And if we look at Indonesia, for example, the requirements of the transition is entirely different. The economics are different. There you have coal electricity being available at 4 to 6 cents per kilowatt hour, very challenging to decarbonize economically. You have huge population growth, you have challenges in food supply. At the same time, you also have many critical minerals being mined in the region. You have geothermal electricity available underground. So I think collaboration with regions that really complement our local view here is absolutely critical. And going back to our educational mission, we also need to make sure our students are very well trained to take this international perspective. I'm very excited about the collaboration with Morocco, for example. And there the requirements are also different. The natural resources are different. Let me bring another example, China. China's energy transition also looks very different than the United States. For example, although China has the largest shale gas availability, but it's very difficult to access. So therefore, China's transition does not include natural gas as a principal energy input. There, the focus is on solar out in the West, for example. Then energy storage becomes very important. And that equation looks also very different from the United States. So I think for our students to be well-trained and well-versed on how to catalyze these important transitions, whether it's energy, mining, minerals, a global view is needed. So I would say Indonesia is a great example, Morocco is a great example, but we should look broadly. India is another one too, because these regions are very different from where we sit. And I think that's important.
No, great thoughts there. Going to Morocco and workforce, and there's a lot of ambition in Morocco. I've been in meetings with OCP talking about green hydrogen and wind energy, and how is it? And since you're in education, is it difficult in Morocco to create a workforce that to sort of enable these ambitions to be realized? What are the challenges for keeping students in the country or and things like that? You yourself went study outside the United States, outside Morocco. What is sort of the feeling at UM6P and other educational institutions on how they can provide the workforce trained to be ready for the future that you're planning for yourselves?
I think that I will maybe talk about the challenges before for the industry. We have evolved the problem of like energy transition, but there is like other challenges regarding, for example, especially sustainable mineral processing within the phosphate industry. We are trying to make a change, but I think one of the most important challenges in making these changes operational is, do we have really the qualified person to work on this challenge? So what we do at university is try to hear from the industry what their needs, for example, regarding energy transition or also sustainable mineral processing, and then provide the necessary courses or training for the industrial people or even for our student. The question is not easy because the question that you ask, do we have the necessary qualification? But what we have done at the model of the university is we brought Moroccan from outside Morocco that went like for several decades experience as United States, in Canada or elsewhere, that will serve as the locomotive for this transformation.
So I want to end with you, Ed, to see if there's any questions. I didn't get any questions here on my Slido, but if you do have, please let me know. You're not in academia, and we are in academia. So I would say, number one, for countries like the United States, where do you see big gaps in the creation of a workforce that, we're talking always about their own mineral supply chain and things like that? So I think, number one, we'd like to hear about that and what you recommend for academia and maybe even Stanford to train people in. And secondly, what is your challenge when you go to countries like Argentina, where it may be very difficult to get a skilled workforce to work there? What are those challenges?
That is, let's look at this. The United States just published, I think there's about, 50 or 60,000 jobs available, looking for, in the U.S. My challenge is, I have a small company, very niche, process controls and, commissioning. We brought in 15 H-1B visa people into the United States, from South America, from Mongolia, from India, from different places, just in the United States, 15 H-1B people. Now, there's not, we do a lot of work with 4 universities in Utah, with U of U, BYU, Utah Valley, and University of Utah and New Mexico State. Trying to get that out there. It's getting the culture. When I say, we can, metallurgical engineering, I'm an electrical engineer, but getting that culture and what we're doing with this, that is where I see there's a gap. In developing, when we work with academia and setting up projects, we want to get these projects that are as real as close as to what a mine is. One of the things that I've seen firsthand, you could get the young kids out of college, great, we train them, develop them, then you put them at the high Andes at 3,000 meters, they come back home. You go even send them to Newfoundland. They live in a man camp. That is very hard. So it's got to be a culture thing. Now, as far as development of people, you got to be hands-on. And one of the things that I've seen is, lack of workforce. People are retiring. People, a little bit older than me, coming out of retirement with that mindset, and it's getting that, get your hands dirty. One of the things we like to do is get our young engineers to do technician work. Start up a pump, feel it, touch it, energize something, prove it, get that inside of you, lose that fear, and be able to do that. In Argentina, there's in fact, when we did a project in Dominican, we brought in a bunch of Argentinians from the oil fields, that great instrumentation people, into a mining project, and we did some cross-training. That was amazing. So you have to look at what's available and also build a culture towards that. And one of the things that I look at personally as a businessman, you're investing money, you're investing your efforts in developing an individual. It has got to be both give and take, and also providing them a good vision for their future. Because at the end of the day, we want them to be successful, us to be successful, and give them a vision of what it is. And I think, in this panel, a lot of people talk about what mining really is for society. It creates indirect jobs. 1 out of 7 jobs mining indirectly creates. It's a catalyst. And when you get people motivated into real sustainability, like you mentioned, energy, water, and all of that, then people have passion to do this. In Morocco, be passionate. Have that, hey, I want to be part of the difference. I want to do something. Yeah, it's not going to be easy, but if you look at it, it's fun. I mean, we get to play in the sandbox. And that's what keeps me excited about this type of industry. But getting that people, getting academia into projects, even getting them involved in actual mindsets. We try to get the young kids into the mindset, get them involved and get them excited. And really, once you change that mindset and you win their hearts, that's where the change happens.
Thanks. Maybe I'll finish then with you, William, and what are your thoughts and visions around our Stanford UM6P? Where would you like that collaboration? Where would you like that to be heading?
Well, first, I had the pleasure to visit UM6P about 2.5 years ago. I'm a researcher in the batteries area, and one of our great colleague, Kelly Ming, is a very good friend of UM6Ps, and he hosted one of our big battery conference there 2.5 years ago. And I agree with Jeff, the assessment that is an extraordinary start. And I think there are great hopes for UM6P to really rise to be a world-class institution. I think there's a lot that Stanford is doing with UM6P, like through this program. Our institute's also in discussion on expanding that partnership. I think the working fluid of any partnership is people. I think this is clear. I think increasing the flow of people both ways, I think it's going to be critical. It's going to take a lot of hard work. There's a lot of already mutual interest. When I went to UM6P, I saw all the labs working on LFP. I'm the only professor at Stanford, almost, working on LFP. And now I don't anymore because of my company and the conflict there.
Yeah.
So I see a lot of commonalities. I'm a little bit, it's humbling to say that the facilities at UM6P for batteries is better than at Stanford. So there's a lot we can learn from UM6P as well. But I think getting this and integrating the innovation, spirit that is very strong here in Silicon Valley with the industrialization spirit of Morocco, I think that's a huge opportunity. Bidirectional learning. And I think how we measure success is how many people are moving back and forth. I know that Jeff also has held meetings in Morocco. I think we should do more. I think we should have exchange students, postdocs, professors, if we can. And I think it's up to people in this room to make it happen.
Absolutely, thank you. Well, I have this one audience question actually, and we're finished with that. And connects to what Will just said is OCP, of course, company that's produced phosphoric acid for a long time. But now, what is the connection going to be with the phosphorus for the batteries? How is that? How are you? The question is, how are you looking downstream that way towards the battery production. Do you know a little bit about that?
Yeah. Yeah, as you said, OCP is like producing phosphoric acid fertilizers since several decades ago. But since 2023, there is a huge industrial ambition from OCP for product diversification. And the first thing is to work on LFP batteries. Recently, there is a lot of startups that started working on that because of, we have what does it take to make the LFP batteries. The first thing is we have the purified phosphoric acid as as a precursor for cathodes. And the second thing, there is the necessary facilities to work on that englobe the collaboration between the R&D by the university, the scale up by the incubator, which is Innovex, and finally the industrialization and the funding by OCP. And I think the second advantage that we have is we have the whole value chain of phosphate, which make things easy to work on that. And finally, we have a good strategic position close to the European market.
Great. Well, let's thank our amazing panel for today. All right, this is the end of it. I thank you all for sticking around, and I think we had an amazing 2 days. I'm still processing a lot of things. I'm connecting with many of you, and if you want to reach out, collaborate with us, you see that Stanford doesn't just do mineral exploration, but also looking at more downstream, midstream, and downstream components that we're looking to expand on. We'd love to hear your thoughts. In any case, great to have you, and wishing you safe travels back home.